Hello and welcome to the next tutorial for the ultimate turn-based battle system for Unity. In this video, we are going to take a look at the Create Enemy tab inside the custom Ultimate Turn-based Battle System window. The Create Enemy tab is mostly similar to the Create Hero tab. A lot of the setup works in the same way. You define a sprite, a name, level-based HP and MP growth, additional stat growth, affinities and skills. So if you already watched the Create Hero tutorial, many parts of this workflow will feel familiar. However, we are still going to go through everything step by step because enemies are used differently inside the battle system. A finished hero prefab is usually added to the hero dictionary and used by the party manager as part of the player's party. A finished enemy prefab is usually added to enemy teams. The enemy team then decides which enemies appear in a battle, at which level they appear, and what rewards can be earned when they are defeated. So while heroes and enemies share many similar systems, the final enemy prefab is used in a different part of the battle workflow. For this tutorial, we will stay on the Create Enemy tab. The Create Enemy tab creates an enemy data asset and an enemy build prefab. The enemy data asset stores the actual enemy information. The enemy build prefab is the game object that will be spawned and used during battle. The enemy data asset contains the values and settings. The enemy prefab contains the runtime components and visual setup that use this data. Now let's go through the tab from top to bottom. At the top of the tab, you can find the Load Enemy button and the Clear button. The Load Enemy button allows you to load an existing enemy data asset back into the editor. This is useful when you want to edit an existing enemy instead of creating a new one from scratch. When an enemy is loaded, the tab restores the enemy sprite, enemy name, max level, growth settings, affinities, and assigned skills. The Clear button resets the tab back to its default values. This is useful when you want to start creating a new enemy and remove the current inputs from the editor. Next, we have the General section. Here you can assign the enemy sprite. The enemy sprite is the main visual sprite that represents the enemy during battle. When the enemy prefab is created, this sprite is assigned to the sprite renderer on the character child object. This is the sprite that will be visible on the battlefield. After assigning the sprite, the editor also displays a preview of it directly inside the tab. This makes it easier to check if the correct sprite has been selected. Below that, you can enter the enemy name. The enemy name is used for the enemy data asset, the generated prefab, and for identifying the enemy in the battle system. Try to use clear enemy names, because these names will help you organize your enemy assets later. Next, we have the Level Settings section. Here you can define the max level of the enemy. The max level controls the level range supported by this enemy. For example, a simple early game slime might have a max level of 20. A common enemy type that appears throughout the game might have a max level of 99. A boss enemy could also have a level range, depending on how you want to reuse it. The max level is important because the Create Enemy tab generates level-based lists for HP, MP, and all additional stats. This means the enemy does not only store one HP value or one strength value. Instead, it stores a full progression table from level 1 up to the max level. This allows the same enemy prefab to be used at different levels. For example, a level 3 slime and a level 15 slime can use the same enemy data and prefab, but the actual HP, MP, stats, and learned skills can change based on the level. Now let's talk about growth settings. The Create Enemy tab contains growth settings for HP, MP, and all additional stats from the Stats tab. Each growth section has a preview curve. This preview curve helps you understand how the value grows over the enemy's level range. For example, if you are editing HP, the preview curve shows how the enemy's HP increases from level 1 to the max level. Each growth section has a minimum value and a maximum value. The minimum value is the value at level 1. The maximum value is the value at the enemy's max level. For example, if HP has a minimum value of 20, and a maximum value of 500, the enemy starts with around 20 HP at level 1 and reaches 500 HP at the maximum level. The editor then generates the values between those 2 points based on the selected growth preset. Unlike heroes, Enemies do not need an EXP growth curve in this tab. Heroes need EXP growth because they can gain experience and level up over time. Enemies usually have their level assigned by the encounter setup. So for enemies, the focus is on how strong they are at different levels, not on how they personally gain EXP. The first main growth value is HP. HP defines the enemy's hit points for each level. The HP system AI component reads this HP list from the enemy data asset. When the enemy's level changes, the HP system AI updates the maximum HP based on the current level. The HP system AI also handles taking damage, restoring HP, clamping current HP between 0 and max HP, and notifying other systems when HP changes. This is used during battle whenever the enemy is attacked, healed, absorbs damage, or receives HP changes from status effects. Next we have MP. MP defines the enemy's mana or magic points for each level. The MP system AI component reads this MP list from the enemy data asset. When the enemy's level changes, the MP system AI updates the maximum MP based on the current level. The MP system AI also handles consuming MP, restoring MP, clamping the value, and notifying other systems when MP changes. This is useful for enemies that use skills with MP costs. For example, a basic slime might not need much MP. A mage enemy could have higher MP. A boss could have enough MP to use powerful abilities throughout the battle. Below HP and MP, we have the additional stats section. The stats shown here come from the Global Stats tab. For example, if your project uses Strength Defense, Magic Defense, Speed, and Agility, those stats will appear here. Each stat gets its own growth settings. This means every enemy can have a different stat curve. For example, a physical monster could have high strength and defense growth. A magic enemy could have high magic strength and magic defense. A fast enemy could have high speed or agility. A slow but powerful boss could have very high HP and strength but lower speed. This is where you can define the enemy's role in battle. Each stat growth section uses the same type of setup. You can define the minimum value at level 1. You can define the maximum value at max level. You can choose a growth preset. You can adjust variation. And you can randomize the seed. The growth preset controls the shape of the curve. Linear creates a steady growth from the minimum value to the maximum value. Ease in starts slower and grows faster later. Ease out grows faster early and slows down later. S-curve creates a smooth progression that starts slower, grows stronger in the middle, and slows again near the end. Exponential creates stronger late-game scaling. Logarithmic creates stronger early growth. JRPG creates a more RPG-like curve with stronger early growth, a more stable middle, and some endgame scaling. These presets make it much easier to create different enemy scaling styles without manually typing values for every level. The variation value adds controlled variation to the growth curve. This can make the generated values feel less perfectly mathematical. The seed controls the variation pattern. If you click Randomize, the seed changes, which creates a new variation pattern while keeping the main settings such as minimum, maximum, preset, and variation the same. When the enemy is saved, the editor builds the full level list from these settings. It also makes sure the values stay safe and do not decrease unexpectedly. This is useful because enemy stats should usually grow or stay stable as the enemy level increases. Now let's talk about affinities. The Affinities section shows all affinities from the Global Affinities tab. For each affinity, you can choose the enemy's resistance type. For example, an ice enemy could resist ice and be weak to fire. A ghost enemy could block physical attacks but be weak to light. A fire monster could absorb fire and be weak to ice. The available resistance types are the same ones used by the rest of the battle system. Normal means the enemy receives regular damage. Weak means the enemy takes increased damage. Resist means the enemy takes reduced damage. Block means the damage is cancelled. Repel means the attack is reflected. Absorb means the enemy is healed by that affinity instead of damaged. These affinity settings are saved into the enemy data asset. At runtime, the Affinity System AI component reads this information and stores it in a dictionary. When the enemy is hit by a skill, the battle system can ask the affinity system AI how the enemy reacts to that skill's affinity. This is what allows enemies to have elemental weaknesses, resistances, immunities, absorption, and repel behavior. Enemy affinities are very important for battle design. They can encourage the player to test different skills, learn enemy weaknesses, and make tactical decisions instead of always using the same attack. Next we have the skills section. Here you can assign skills to the enemy. To add a skill, click the Add Skill button. This creates a new skill entry. Each skill entry has a skill data reference and an unlock level. The skill data reference is the actual skill that the enemy can use. The unlock level defines at which level the enemy has access to that skill. For example, a Firebat could use Bite at level 1. At level 5 it could learn Fireball. At level 10 it could learn Flame Burst. A boss could start with basic attacks at lower levels and unlock stronger attacks at higher levels. If you no longer need a skill entry, you can click the Remove button to delete it from the list. These skills are saved into the enemy data asset. At runtime, the skill system AI component checks the enemy's current level and determines which skills are learned. If the enemy's current level is equal to or higher than the unlock level, the skill is considered learned. If the enemy is below the unlock level, the skill is not learned yet. This allows the same enemy to behave differently depending on its level. A low-level enemy can use simple skills. A higher-level version of the same enemy can use stronger or more advanced skills. This is very useful if you want to reuse enemy types across different areas of your game. Now let's talk about saving the enemy. At the bottom of the tab, you can click Save Enemy. When you save the enemy, the editor creates or updates an enemy data asset. The enemy data asset stores the enemy sprite, enemy name, max level, HP growth, MP growth, stat growths, generated level lists, affinities, resistances, and skills. After the enemy data asset is saved, the editor also creates or updates an enemy build prefab. This prefab is the actual enemy game object used by the battle system. If a prefab for the enemy already exists, the editor updates it. If no prefab exists yet, the editor creates a new one. Now let's look at the structure of the generated enemy prefab. The root game object is named after the enemy and uses the enemy tag. This root object contains the main enemy components. The first important component is the enemy data holder. The enemy data holder stores a reference to the enemy data asset. This is the connection between the enemy prefab and all the data that was created in the editor. Many other enemy systems use the enemy data holder to find the enemy's data. For example, the level system AI, HP system AI, MP system AI, stat system AI, affinity system AI, and skill system AI all rely on the enemy data from this component. The enemy data holder also has a custom inspector that displays a small overview of the assigned enemy data, such as the enemy name and max level. Next, the prefab gets a level system AI. The level system AI manages the enemy's current level. It reads the max level from the enemy data asset and makes sure the current level stays inside the valid range. When the level changes, the level system AI triggers a level changed event. Other systems, such as HP, MP, and stats, can respond to this level changed event and update their values. The enemy level is especially important because enemies are often spawned through enemy teams. The enemy team can define which enemies appear and what level they should have. This means the same enemy prefab can be reused in many different encounters with different levels. Next, the prefab gets the HP system AI. The HP system AI manages the enemy's current HP and max HP. It reads the level-based HP values from the enemy data asset. When the enemy takes damage, the HP system AI lowers the current HP. When the enemy is healed, it restores HP. It also makes sure HP does not go below 0 or above the current max HP. The HP system AI raises an event when HP changes, so UI and other systems can react. Next, the prefab gets the MP system AI. The MP system AI works very similarly to the HP system AI, but for MP. It reads the level-based MP values from the enemy data asset. It handles consuming MP, restoring MP, clamping the value, and raising an event when MP changes. This is used when enemies use skills that cost MP or when status effects restore or drain MP. Next, the prefab gets the Stat System AI. The Stat System AI calculates the enemy's current stats. It starts with the base stat values from the enemy data for the current level. Then it adds runtime flat modifiers such as status effect buffs or debuffs. So the final stat value is built from base stats and status or buff modifiers. This is slightly different from the hero stat system because heroes also have equipment bonuses. Enemies do not use the same equipment system by default. Their stats are mainly based on their level-based enemy data and runtime status effects. The Stat System AI also supports breakdowns, so the inspector can show where stat bonuses come from. For example, an enemy could have a base strength value and a temporary strength up bonus from a status effect. Next, the prefab gets the Affinity System AI. The Affinity System AI reads the enemy's affinity and resistance setup from the enemy data. It provides the current resistance type for a given affinity. For example, the battle system can ask the enemy, "How do you react to fire?" And the Affinity System AI can return normal, weak, resist, block, repel, or absorb. This system is used during damage calculation and battle reactions. Next, the prefab gets the Skill System AI. The Skill System AI reads the enemy's skill list from the enemy data. It checks the enemy's current level and determines which skills are learned. This allows the enemy turn logic to know which skills are available for the enemy. An enemy can have many skills assigned, but only the skills with an unlock level equal to or below the current level are considered learned. Next, the prefab gets the Status Effect System AI. The Status Effect System AI manages all active status effects on the enemy. It can apply HP changes, MP changes, stat buffs, stat debuffs, percent-based effects, damage over time, healing over time, and duration handling. For example, Poison could subtract HP each turn, Regeneration could restore HP each turn, Strength Up could add a flat bonus to the Strength stat, Defense Down could subtract from Defense. The Status Effect System AI also handles durations like until next turn, number of turns, random duration, or until the end of battle. When a status effect is removed, the system can also remove the stat modifiers that came from that effect. The generated enemy prefab also contains a child object called Character. The Character child contains the visual and animation setup. It has a sprite renderer for the enemy sprite. It has an animator. The animator uses an animator override controller that is created for this enemy when the enemy is saved. The animation clips that come from this override controller already contain animation keyframes that animate the enemy sprite assigned in the Create Enemy tab. This means that the enemy sprite is not just placed on the battlefield as a static image. The generated enemy already has working base battle animations, using the selected enemy sprite. So all enemy sprites are already animated by default. Of course, you can still customize this completely. You can edit the generated animation clips directly with keyframes. You can replace them with sprite sheet animations. Or you can create entirely new animations, including more advanced setups like bone animation, depending on how your character artwork is built. This gives you a ready-to-use animated enemy immediately, while still keeping the animation setup flexible for your own project. Next is the Character Animation Handler. The Character Animation Handler is very important because it connects animation events back to the battle state machine. For enemies, this is especially important during enemy turns and enemy death handling. For example, when an enemy attack animation ends, the animation event can call the handler. The handler then tells the enemy turn state that the attack animation has finished. The same idea applies to take damage animations, block animations, repel animations, absorb animations, spawn animations, despawn animations, and death animations. When an enemy death animation ends, the handler can notify the update battle state so the enemy can be cleaned up correctly. This allows the battle system to wait for animations and continue the battle flow at the correct moment. When the enemy is saved, the editor also creates an animation folder for that enemy. It creates or updates an animator override controller based on the battle character base controller. This makes it possible for every enemy to use the same general animation structure while still having their own animation clips. For example, each enemy can have their own idle, attack, take damage, block, absorb, death, spawn, and despawn animations. The editor also creates or updates helper objects called turn indicator origin and target indicator origin. These are placed based on the enemy sprite bounds. The turn indicator origin is placed near the bottom of the sprite. The target indicator origin is placed near the top of the sprite. These origins help the battle system and UI place indicators in a clean and consistent way. For example, the turn indicator can appear below the enemy, while the target indicator can appear above the enemy. This saves time because you do not need to manually create these helper points from scratch for every enemy. The enemy prefab is now ready to be used in enemy teams. Once the enemy is part of an enemy team, the battle system can spawn it during battle. Now let's talk about how the finished enemy prefab is used differently from a hero prefab. A hero prefab is usually part of the player's available party. It is connected to the hero dictionary and party manager. The player can bring heroes into battle, switch them, gain experience, level them up, and use them across multiple battles. An enemy prefab is usually placed into an enemy team data asset. The enemy team decides which enemies appear in a specific encounter. It can also define levels, rewards, drops, and how many enemies are part of the battle group. Then an encounter uses that enemy team to start a battle. So the basic workflow for enemies is: create the enemy, create or edit an enemy team, add the enemy prefab to the enemy team, set the enemy level and rewards, assign the enemy team to an encounter, start the battle. This is the main difference between heroes and enemies. Heroes are player party members, enemies are encounter content. In the next tutorials we will continue with the other tabs of the Ultimate Turn-Based Battle System window and look at how they work together to create complete turn-based RPG battles. Thank you for watching. If this video helped you, please leave a like and subscribe to the channel for more tutorials and updates about the Ultimate Turn-Based Battle System.